in this example, we've got a particle where we've got three force vectors acting on this particle. So I've tried to show you each of these vectors acting on this particle, which is in the middle here. So we've got one vector, which is 2i plus 1j. So that's a force 2 newtons to the right and 1 upwards, for example. And in part A, we're asked to find out what the resultant force is on this particle. So that word resultant force means what do you get if you add together all of the forces that are acting on the particle? So let's do that in vector form. So we've got minus 1, 4, plus 3 minus 2, plus 2, 1. And if we add them together, we're going to have 4. And we're going to have, so that's our horizontal force, overall force. And if we add together the vertical forces, we're going to have 3 vertically. So what that means is if I add together all of these vectors, it's equivalent to a single vector, 4, 3. So if we were to draw that on our diagram, this is our resultant force heading in that direction. 4 to the right and 3 up. And that's what we call our resultant force. So what we could do is we could remove all of these coloured forces and just replace it with that single black force, the resultant force. So in part A, we're asked to actually write it in the form Pi plus Qj. So at the moment it's in column form, so all I need to do is write that as 4i plus 3j. In part B, we're asked to find the magnitude of the resultant force. So we're asked to find the magnitude of this vector here. Well, we know how to find the magnitude of that vector, it's just the length of that vector. So let's draw ourselves a diagram. R looks like that. And we know that R goes to the right by 4 and it goes up by 3. So the magnitude of R is going to be the length of that line, that hypotenuse. So we're just going to use Pythagoras. So it's the square root of 3 squared plus 4 squared, which is 5. So the magnitude of that resultant force is 5. We're also asked to find the bearing of the resultant force. So remember that a bearing is the angle measured from straight up, from the j direction, or from the north direction. So we want to find out what is that angle theta labelled on our diagram. So perhaps it's easiest if we find out what this angle alpha is first, because we've already got our right angle triangle here. So we know from our diagram that tan alpha, using the right angle triangle, tan is opposite over adjacent, so 3 over 4. So if we solve that, we find that alpha equals inverse tan of 3 over 4, which is 36.869. ... So we were asked to find out what the bearing is. So the bearing, theta, is going to be equal to 90 minus 36.869. And if we round that to 3 significant figures, we get 53.1 degrees. So that's the bearing, and the magnitude was 5. So in part C, we're asked to describe the motion of the particle. So if we go back to our original diagram, we know that we can replace all of these coloured vectors with this single black vector r. So if you imagine you've got that particle and we apply that single force r to it, what's going to happen is that particle is going to accelerate in the direction of r. So that's our answer to C. The particle is going to accelerate in the direction of r. And I'm actually going to say accelerate in the direction of the resultant force.